Hello everyone, welcome back to this online class. Today we are going to look at how to show that sine raised to 6 of 2x is equals to 1 over 32 cos 12x plus 3 over 16 cos 8x minus 15 over 32 cos 4x plus 5 over 16. Now we have two methods of showing the given identity. The first method, we are going to use what is called Euler's identities. So let me write. Method one is using Euler's identity. Remember, I want us to take note that exponential I to x is the same as cosine of 2x plus I sine 2x. We also know that exponential negative I to x is equals to cosine of 2x minus I sine 2x. I want to make sine 2x the subject, so what I'm going to do here is to subtract the two equations because I need sine 2x. I need to know what is sine 2x in terms of the exponential function. So when I subtract the equation 1 minus equation 2, I'm going to get this. I'm going to get exponential I to x minus exponential negative I to x. That is the same as 2i times sine 2x. So now make sine 2x the subject. So we can now say therefore sine of 2x is equals to exponential I to x minus exponential negative I to x, everything divided by 2i, or what you can write as I2. That is the identity for sine 2x. You can write sine theta in terms of exponential function in this form. So now we need to expand this. We need to raise it to power 6 on both sides. So we now say therefore, remember the I here, you can take note that this I is a Greek symbol. It's called iota. It is the same as the square root of negative 1, iota. So I'm going to bracket this. This is called iota, a Greek symbol read as iota, the square root of negative 1. Now let's see, how do we raise sine 2x to the power of 6? So you can say therefore, or hence, sine raised to 6 of 2x is the same as exponential I to x minus exponential negative I to x, everything over I2, and this is raised to 6, which you can write as 1 over I raised to 6 times 2 raised to 6, which is 64, then times exponential I to x minus exponential negative I to x, and this is raised to 6. Remember the binomial expansion, a minus b raised to 6 Remember the binomial expansion of a minus b raised to 6? And before that, this can be written as take note that I raised to 6 is the same as I raised to 4 times I raised to 2. I raised to 4 is negative 1 raised to 4. That is 1. I raised to 2 is the same as a square root of negative 1, then you square it, that is negative 1. I said I raised to 4 is the square root of negative 1 raised to 4. So the answer here is negative 1. So I raised to 6 gives us negative 1. So we expect this to be equal to negative 1 over 64 times exponential I to x minus exponential negative I to x, and this is raised to 6. Now take note again, binomial expansion. Take note that when you have a minus b raised to 6 is the same as a raised to 6 minus a raised to 5 times b. Of course, the coefficient is 6. Let me write the coefficient. When you're expanding a binomial, that is raised to 6. So minus 6 a raised to 5 times b. And the other one is plus 15 a raised to 4 b squared minus 20 a raised to 3 b cubed plus 15 a squared b raised to 4 minus 6 a b raised to 5, and then lastly plus b raised to 6. So in the expansion of exponential I to x minus exponential negative I to x, we're going to say let a be exponential I to x, and our b is exponential negative I to x. So we can make this substitution. So you can now say that put a is equals to exponential I to x, and b is equals to exponential negative I to x in this expansion. So therefore, what do we get? We want to get this. Therefore, exponential I to x minus exponential negative I to x. This should now give us exponential, because it is a raised to 6, so we raise that to 6, that is exponential I 12 of x. Remember the laws of indices. And then I can see minus 6, a raised to 5 is exponential, that should be exponential I 10x times b, which is exponential negative I 2x. Then there's 15. A raised to 4 is exponential I 8x. B squared will give us exponential negative I 4x. Then minus 20. There's a cubed, that is exponential I 6x. Again, b cubed exponential negative I 6x. Then we have 15. A squared is exponential I 4x. There's b raised to 4, that is exponential negative I 8x. Then I can see there's a negative 6ab raised to 5. So I'll write that. Minus 6, a is exponential I to x. Now b raised to 5 will give us exponential negative I 10x. And lastly, there is plus b raised to 6. I want it to fit along this line. So let me take this to the left. So this will be a plus exponential negative I 12x. Let me simplify this. If you simplify, it will give us exponential I 12x minus 6 exponential I 10x minus 2x, that is 8x, plus 15 exponential I 4x minus 20 plus 15 exponential negative I 4x minus 6 exponential negative I 8x plus exponential negative I 12x. And then I can now group them with the same as exponential I 12x plus exponential negative I 12x. So that's one group. Then there's minus 6 outside, exponential I 8x, then plus exponential negative I 8x. Then you can see there's a plus 15 exponential I 4x plus exponential negative I 4x. Then lastly minus 20. So that is the expansion of course this was raised to 6. Let me add it here. I didn't, this is raised to 6. Correction. So now we have expanded that binomial, and we have found the result in as exponential I 12x plus exponential negative I 12x minus 6 exponential I 8x plus exponential negative I 8x plus 15 exponential I 4x plus exponential negative I 4x, then minus 20. Now let's go back to our expansion for sine raised to 6 of 2x. Look at where we are. Let me take it here. I'm going back to that equation. We said that's supposed to be negative 1 over 64 times the expansion of exponential I 2x minus exponential negative I 2x raised to 6. So you can now say therefore, let me write it here. You can now say therefore, sine raised to 6 of 2x can now be written as negative 1 over 64 times our expansion was exponential I 2x, that is 12, I 12x plus exponential negative I 12x minus 6 exponential I 8x plus exponential negative I 8x plus 15 exponential I 4x plus exponential negative I 4x minus 20. And this you can also write as negative 1 over 32 outside. Then inside, we can write this as exponential I tail of x plus exponential negative I, that's negative tail of x, divided by 2 minus 6 exponential I 8x plus exponential negative I 8x divided by 2 plus 15 exponential I 4x plus exponential negative I 4x divided by 2 minus 20 over 2. See, I've taken the 2 inside so that we have 32 times 2, which is 64. So I want us to recall the cos theta. How do you write cos theta in terms of exponential function? Remember, cos theta is the same as exponential I theta plus exponential negative I theta over 2. Let me write it here. Take note that cosine of theta is the same as exponential I theta plus exponential negative I theta. And the whole of this you divide by 2. Divide by 2. So that's the identity we are going to use here, so that our result can now be written as this is now equal to negative 1 over 32 times, this is the same as cosine of 12 of x minus 6 cosine of 8x plus 15 cosine of 4x minus 10. And so if I open the entire bracket, I'm going to get this. It will now be equal to negative 1 over 32 cosine of 12 of x plus 6 over 32, which is the same as 3 over 16 cosine of 8x minus 15 over 32 cosine of 4x, then plus 10 over 32, which you can write as 5 over 16. So we have shown that sine raised to 6 of 2x can be written as negative 1 over 32 cosine of 12 of x plus 3 over 16 cosine of 8x minus 15 over 32 cosine of 4x plus 5 over 16. That is the first method when we use the Euler's identity. When you express sine of 2x in terms of the exponential function. So there's another method. Let's call it method 2. I'm going to write. So method 2, you're going to write this. Let me write here method 2. So method 2, we are going to use the Moivre's theorem. So here you write using, let me use a different color, using the Moivre's theorem. Remember the de Moivre's theorem? It is z raised to n. If z is equals to cos theta plus I sin theta, then it means that z raised to n is the same as cos n theta plus I sine n theta. That is the case where the modulus is 1, r. Because usually z is equals to r into cos theta plus I sine theta. If you had r, a number different from 1, then you'll have raised it to power n. So that's the de Moivre's theorem. So now, this is what we say. We're going to say let z be equal to cosine of 2x plus I sine of 2x. So this means that 1 over z is the same as z raised to negative 1. So apply the Moivre's theorem here. In this case, our n is negative 1. This will give you cosine. It's like you are taking z raised to negative 1. That will give you cosine of negative 2x plus I sine of negative 2. But remember, cosine of negative theta, take note, let me write it here. Take note that cos of negative theta is the same as positive cos theta. Cosine is an even function, and also if you have sine of negative theta, is the same as negative sine theta. So sine is an odd function. We are going to use this identity. So therefore, this can now be written as cos 2x minus I sine 2x. Now you can get cosine z raised to 6 and even z raised to negative 6 in that order using the de Moivre's theorem. Now I want to take z minus 1 over z. What are we going to get? So therefore, z minus 1 over z, this should give us, I'm subtracting, take this, the whole of this minus this one. It is, let me write it. It is cosine of 2x plus I sine 2x, that is z, minus 1 over z, we got cosine of 2x minus I sine of 2x. I am subtracting because I need to know what is sine 2x, because I want to make sine 2x the subject. If you will have added, you will have found cos 2x. But in this case, we need sine 2x. So when you subtract, you get, of course, the cos 2x will cancel. We get 2i sine 2x. 2i sine 2x. So let me raise this to power 6. So therefore, z minus 1 over z raised to 6 is the same as 2i sine 2x, and this is raised to 6. On the left-hand side, use the binomial expansion of a minus b raised to 6, which I wrote up previously. If we expand this, where a, this is our a, and this is our b. Remember, a minus b raised to 6. So that should give us a raised to 6, so that is z raised to 6, minus 6 z raised to 5 times 1 over z plus, that is plus 15 z raised to 4 times 1 over z squared minus 20 z raised to 3 times 1 over z cubed plus 15 z squared times 1 over z raised to 4 minus 6 z times 1 over z raised to 5 and then plus 1 over z raised to 6. So this one should be able to give us the right hand side is 2 raised to 6 is 64. 64, then I raised to 6, I raised to 6, then times sine raised to 6 of 2x. But we said I raised to 6 is the same as negative 1. That's what we said. I raised to 6 is negative 1. So you can take note. Take note that I raised to 6 is the same as negative 1. Because I is the square root of negative 1. So on the left hand side, if I simplify this, I'm going to get z raised to 6 minus 6z raised to 4 plus 15 z squared minus 20 plus 15 times 1 over z squared minus 6 times 1 over z raised to 4 plus 1 over z raised to 6 is the same as negative 64 sine raised to 6 of 2x. And so I can group the left-hand side. If I group the left-hand side, I'm going to get this, or z raised to 6 plus 1 over z raised to 6 minus 6 z raised to 4 plus 1 over z raised to 4. Then I can see plus 15 z squared plus 1 over z squared. Then minus 20 is equals to 64. That's negative. Let me write negative 64. It's another color. Negative 64 sine raised to 6 of 2x. So now we need to ask ourselves, what is z raised to 6? And what is 1 over z raised to 6? When you add them, what do you get? Let me explain this. Take note. Take note that z raised to 6 using the Moivre's theorem is the same as, is a note, NB, is the same as cosine. Look at our z, and we want to use the Moivre's theorem. Let me take you up. Our z was this one. You can take it, that. So it is this that you're going to raise it to 6. This one raised to 6. Our 1 over z, or z raised to negative 1, is this. So when it is 1 over z raised to 6, it is z raised to negative 6. So that means the argument you multiply by n. N in this case is 6, so all those arguments will be multiplied by n. Our modulus is 1, so 1 raised to anything is just 1. So this will give us cosine of 12x plus I sine of 12x. Now, what about 1 over z raised to 6? 1 over z raised to 6 is the same as z raised to negative 6, which will give you cosine of 12 of x minus I sine 12 of x. So we are adding. If I add the 2, I'm going to get z raised to 6 plus 1 over z raised to 6 to be equal to twice cosine of 12 of x. Similarly, let's work out z raised to 4 plus 1 over z raised to 4. So z raised to 4 is equals to cosine of 8x plus I sine of 8x. 1 over z raised to 4 is the same as z raised to negative 4, which is equals to cosine of 8x minus I sine 8x. Again, I'm going to add these two. When I add them, I'm going to get z raised to 4 plus 1 over z raised to 4 to give us 2 cosine of 8x. And finally, we need z squared plus 1 over z squared. So let me take this to the left and write this one for z squared. Finally, we have z squared is the same as cosine of 4x plus I sine of 4x. What about 1 over z? 1 over z squared is the same as z raised to negative 2. And so this is cosine of 4x minus I sine of 4x. So again, we are going to add these two. We add them to get this. So we are going to get z squared plus 1 over z squared is equals to twice of cos 4x. Now, go back to this equation. Let me call it equation star here. Look at our equation star. I am going to substitute those results. So therefore, equation star becomes our equation star. Equation star will now become, we substitute. The first one is 2 cosine of 12 of x. The other one is minus 6 times 2 cosine of 4x. The other one is plus 15 times 2 cosine. No, the other one is, this one is 8x, not 4x. Here. Let me rub it. This one should be 8x. The other one is 2 cosine of 4x. That's what we got. Minus 20 is equals to negative 64 times sine raised to 6 of 2x. You can see we can as well divide by 2 because I can see 2 is common. If I divide both sides by 2, I'm going to get this, or cosine of 12 of x minus 6 cosine of 8x plus 15 cosine of 4x minus 10 is equals to negative 32 sine raised to 6 of 2x. So make sine raised to 6 of 2x the subject. So you can say therefore sine raised to 6 of 2x, we make it the subject. So this should be equal to, we are dividing by negative 32. So we get negative 1 over 32 cosine of 12x. Then here now we'll have 6 over 32, which is the same as 3 over 16 cosine of 8x. Then we have minus 15 over 32 cosine of 4x plus 10 over 32, which is 5 over 16. So this is another method of verifying the identity for sine raised to 6 of 2x. So thank you all for watching. Please don't forget to subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Prof. Francis Okech or just Francis Okech, and you'll find me right there. Subscribe to the channel, share, comment, and like the videos. So when we meet next time, we look at other problems in complex analysis. Bye-bye.